So guys, I have this simple question. This is what we'll be resolving as our first practice question, okay? And in this question, I'm going to show you almost everything, right? We have three forces to be resolved, okay? Note that any force that is falling purely on y or purely on x need not to be resolved, which means need not to be broken, okay? It will be presented for y and it will also be presented for x, okay? But when a force is falling between x and y, this is a z-axis. You only tamper with these forces falling on z-axis, okay? Another thing to note is that this angle here is an angle to the horizontal. Why do I call it an angle to the horizontal? If I have something like this now, okay, just like we have there, this F2, okay? Now, this angle here is called angle to the horizontal because it's sharing a borderline with the horizontal line, okay? So this was given as 30 degrees. So this is angle to the horizontal. Now, if the angle is given here, right, the angle will not be angle to the horizontal because the arc is sharing a borderline with the vertical line, which makes it what? Which makes it angle to the vertical, right? And it's as simple as that. Don't forget the whole of this place is 90 degrees. I've shown you that before. The whole of this place is 90, this place is 90, this place is 90. So because this place is 30 degrees, automatically this place would, since it is 90, it will now be 90 minus 30, and that will give you 60 degrees. So which means that this whole place is going to be 60 degrees. If you're also given 60 degrees here or 30 degrees, this place will going to be 60 degrees, and that's how it works. Whenever you're dealing with questions like this, ensure that your angle is towards the horizontal. This question, for instance, the angle is actually to the horizontal, which is fine, okay? But sometimes the angle might be given to the vertical. When the angle is given to you towards the vertical line, what you try to do is that you forfeit the angle at the vertical, okay? Or angle towards the vertical, and try to solve the remaining that is at the horizontal. That is what you'll be using to solve your question. You see, if you have your angle towards the horizontal, you can easily use cos here, right? And you can still use that 30 degrees for your sine whenever you're dealing with y-axis, because y-axis is always talking about sine and x-axis is always talking about cos. Now let's resolve and see what's going to happen. So I'm picking a starting point, which is f3, all right? So I'm resolving towards x-axis and I'm also resolving towards y-axis, okay? So this sign I wrote here actually is sum, okay? Sum of forces towards the y-axis and sum of forces towards the x-axis. That's what the sign represents. Okay, so the first force on x-axis is actually F3. So I'm going to say F3. Now, what kind of F3 is it? Is it a negative F3 or a positive one? It's a positive one because the F3 is towards positive x-axis. So whether I put my plus here or not, I'm going to have F3, okay? It's still plus F3. Now, why am I not adding cos or sine to this F3? Because it's purely x. I don't need a cos or a sine for it. It's as simple as that. You know, I've picked this F3 as x-axis. Now, can I resolve that same F3 for y-axis? The answer is no. Why? Because this F3 is purely an x-axis component or an x-axis force, okay? So it cannot play as x and still play as y. Never. The only force that can do that is F2. It's falling as z. Do you understand? And because it's falling as z, it's falling in between y and x. It's also have a component in y and it's also have a component in x. That's as simple as that. Now, let's move to F2. So since I have F2 here, what's going to happen? Here for F2, I have to resolve the force towards x-axis. Do you understand? It will be as if I'm bringing the force to be in line or to align with this line, okay? So I'm resolving towards the x-axis. Now note that the x-axis I'm resolving to is actually the nearest x-axis, which is positive x-axis. I cannot bring it to negative x-axis, no, because it's not near to it. Do you understand? But this guy is near to it, so I'm resolving towards the positive x-axis. Because I'm resolving towards the positive x-axis, it will be plus, okay? Because I'm resolving towards the positive, then it will be plus the force, then the trig ratio, which is cos, right? Cos 30 degrees. Why am I using an angle for this? Why didn't I use an angle for this? I didn't use an angle for this because this is purely on x-axis, and the angle I should have just used for it is supposed to be 0 degree that I showed you earlier on, that this place is 0, this place is 90, this is 180, this place is 270, and this place can be 360. Do you understand? So if I press it, if I write f3 cos 0 degree, okay, hadn't been I want to use that 0 for it because it's falling on purely on 0, okay? So it will be f3 times 1, which will be equals to f3. So it's just a waste of time to keep writing that 0 or 360. Do you understand? So instead of writing that 360, let me just put it as f3 and leave it like that. That's why we're not using an angle for it. So because we believe that this sign here, the plus here, has done the justice to the cos 0 that we want to actually add to it. Do you understand? So in that sense, I can forget about that. So I'm still dealing with the f2 quickly. So I'm resolving the f2 towards the x-axis. So resolving it towards the x-axis, I have f2 cos 30 degrees. Cos 30 degrees. So the first thing you pick is the first. The next thing is the cos, then the 30 degrees. And it's as simple as this. Now, you are not done with the f. Why? Because the f2 is falling on z-axis. Because it's falling on z-axis, what will happen? You will resolve towards x-axis, and you also have to resolve towards y-axis, which means that it must have two components. It must have a component on x-axis, and it must also have a component on y-axis, and it's as simple as that. So what am I going to do? I have to resolve towards y now. So I'm dealing with y. So it can be resolved to y. So if I want to resolve to y, what am I going to do? I'm picking the force, which is f2. But before I pick the force, I must determine the sign of the force. So I will ask myself, the y I'm resolving it towards, is it a plus y or a negative y? The answer is plus y. Because of that, I will assume that the sign here is positive, or I put it there. It's fine. Do you understand? So while resolving down to this place, now while resolving towards this y-axis, it won't affect this f2. This f2 have no business or has no business with this guy. Do you understand? So just resolve and pretend as if the f2 is not there. So what do you have? If you resolve here, you have f2, right? But whenever you're dealing with y-axis, what are you dealing with? You're dealing with a sine. You're dealing with sine on y-axis. So which means that I'm having sine what? I'm still using the angle, sine 30 degrees. I'm not changing the angle. So the fact that I'm resolving this towards the y-axis does not mean that I have to use the remaining value here, which is 60 degrees. No. If you want to do that, if you want to use the 60 degrees, you cannot use sine. Then you'll be saying f2 cos 60, which of course, as a student, it will keep confusing you till you finish your study in physics. Do you understand? So instead of changing the cos and sine anyhow you like, okay, just ensure from the beginning of the solving that your angle is at the horizontal. These things have implication when you get to complex level of physics, okay? Now, because your angle is always here, just have it at the back of your mind that this place must be cos and this place must always be what? Always be sine. Do you understand? But if you see somebody that is changing it for you, like the person is using sine here and using cos here, by the time the person is faced with exam tension, the person can just switch the trig ratios. The person can eventually end up using a sine here and end up using a cos here for the same angle, which will result to 0. Do you understand? So you just have a pattern that you work with, okay, right? So you just know that this place is sine, and this place is cos, and this place is y-axis, right? So I go back to f2. I've resolved f2 towards the x-axis, and I got f2 cos theta, cos 30 degrees. And resolving here, I'm not changing my angle. My angle remains. So I have f2 sine 30, that same 30, sine 30 degrees. And it's as simple as that. But am I done? I'm done with f3, I'm done with f2, but I'm not done with f1. Okay, so what am I going to do to f1? Note that this f1 is a y component, purely y, because it's purely on y-axis. Do you understand? And the F1, because it is on y-axis, it cannot play a role in x. Neither it can play a role in z. In short, z, you are not going to account for z. The only two axes you are going to account for is only y and x. Do you understand? The angle here, you know the angle here, right? Because is a default angle. The angle here is actually 90 degrees. So even if you pick it as, because it's f is on y-axis, I'm going to pick it as plus f1, right? F1, and now I'm supposed to leave it like that because it's on y-axis. I'm picking it as plus because it's towards positive y-axis. Now, if you don't want to leave it like that, you can put your sine what? There's a default angle here, which is 90 degrees, sine 90 degrees. But adding sine 90 degrees is still plus 1. So when you multiply plus 1 with f1, it's still going to be f1. So it's just that you can just leave it like this. Do you understand? It will still give you the same answer. All right, this is how to resolve a force whenever a question is given to you. All right, let's try these two questions, okay? So the instruction to the question is resolve the forces in the diagram below, okay? So we have the first question. I want to resolve this force. Okay, I didn't give you an angle. All right, so let's assume that I didn't give you an angle, right? But let me give you an angle for the second one, which is 20 degrees. Let's assume I didn't give you an angle for this question. What do you do when an angle is not given for the z-axis? The only place you need an angle is for the z-axis, okay? But whenever an angle is not given, what do? You take the angle as 45 degrees, which means that the examiner has given you a blank check to use any angle of your choice. But don't forget that for an examiner to do that, it means that he has divided this space, which is 90 degrees, into two. Do you understand? Which means that the angle you're using towards the horizontal now will be 45 degrees. And it's as simple as that. So let's see how we can resolve this force or these forces and see what our answer would eventually be. So for x-axis now, don't forget your x-axis here is your positive x. Your x here is your negative x, right? Your x, this is y-axis. Your y here is your positive y, and your y here is your negative y. Do you understand? So let's see how that would impact what you're solving. So I'm resolving towards x and y axis. So I'm having sum of forces, okay? Sum of forces on y-axis. I can decide to do y first before x or x before y. It's fine. So if you start with y, don't worry. You can still pick this as your starting point. So this being your starting point, this x-axis force, okay, is purely on x-axis, right? An x-axis force cannot play under y. So account for forces, the sum of forces on x. So when you see x-axis force, account for it there. So since it is on positive x-axis, and you know we don't use an angle for when the force is purely on x or purely on y. And if you would have to use an angle, the angle here must be 0 or 360 degrees. And don't also forget that this place, this is still positive x, right, axis, but this place is basically cos that you're using, okay? Since you know that you're using cos, then it will be 1 cos 0 degree or 1 cos 360 degrees. Does that make sense? But since I'm not using, for me, I don't use an angle there. Do you understand now? Not because I don't know that the angle is 0 degree or 360 degrees, but because I believe that and I know that whenever you press cos 0 is going to give you 1. And that 1 times 1 will give you 1 eventually. So what I just do is that I can place the 1 there like that. So what am I going to have? This is going to give me 1 for x-axis. It has no component on y-axis because it's purely on x. It's a default force. Does that make sense? Now, for this guy here, we're going to have a force here, okay? The force is actually on z-axis. Because the force is falling on z-axis, what's going to happen to that force? What's going to happen to that force? Such force, we have to resolve it towards y-axis and towards what? X-axis. Does that make sense? Now, for us to resolve it towards x or towards y, what do? We use an angle. And the angle must be this angle here, All right. So since I have an angle here and the angle is 45 degrees, resolve it towards x-axis, right, first. And if you want to resolve towards y-axis first, you're free. Okay, but I'm doing x first. Now, if I resolve it towards x-axis, which kind of x am I resolving into? Positive x. Do you understand? Which means that the answer is going to, the value must be a positive value. Hence, since I'm going to x, I'm still dealing with this x-axis. So if I bring this here, forget about the force you are meeting here. It has no effect on you bringing this one towards x-axis. So what are you going to have? You're going to have plus the force, okay? I'm picking the plus because the x I'm resolving towards is positive x. So I have the force, then the angle, the trig ratio, which is cos, then the angle, which is 45 degrees. And it's as simple as this. Do you understand? So it means that you need three components for you to resolve z-axis. You need the force. Oh, no. You need the sine. Okay. The next thing is that you need the force that you're resolving. And the last thing is that you need the trig ratio with the angle, which is 3. Do you understand? The force, the sine, the force, and the trig ratio is as simple as that. Now, this same force, I am not done with it. Since I am not done with it, because if you resolve it to x, right, it's not purely an x component, it's a z component. So it has to have a component on x and also on y. Do you understand? So which means that I have to still resolve it towards y-axis. If I resolve it towards y-axis, it's coming towards positive y, which means that I am having a sign of plus, then I have 3, okay, which is the force. Then the last thing I need is trig ratio. So I have, what's the trig ratio? The value you can use here, the trig ratio you are using on y, because you're resolving towards y, is actually sine. So I'm going to have sine what? Sine the same angle I used for cos, which is sine 45 degrees. Okay, sine 45 degrees. All right, which means that I'm done with this z-axis. If you check the 3 very well, the first 3, it has component on fy, it has also a component of sum of fx, which means I'm done. Now, is there any force here? There is no force there, so forget about that part. Now, this one is purely on x, which means that it cannot have component on y at all because it's purely on x. In that sense, what do? You just present it, okay? Whether you present it as minus 6 direct or you present it as 6 cos 180 degrees, which would eventually, if you press 6 cos 180, it's still minus 6. So just present it without using the default angle. Do you understand? So what am I going to have? So for x-axis, I'm going to have minus 6 for this force. Do I need to add the minus 6 to y-axis? No, you don't need it, okay? Because it is not a y component, neither is it a z component. It is purely x and it must be accounted for only x, okay? Then we have this last force, which is 12. Now, this 12 can only play as a y force, okay? Can only play as a y-axis force. Why? Because it's falling purely on y. And whenever you want to account for it, you can pick it direct, since the angle here is a default angle. The default angle is 270 degrees. Do you understand? Is it that you say 12 sine, because you're dealing with y-axis, 12 sine 270 degrees, which when you press it on the calculator is going to give you minus 12, okay? Or you just pick the sine, I'm dealing with y, which is minus, okay? Then you pick the force. You don't need the angle again, because once you pick, if you pick it like this, right, and you add the angle, which is cos 270, it will change the sign again. Do you understand? So you don't need the angle. Whenever you're dealing with y-axis, you don't need the angle. Okay. Now, what do you do after getting these values? What you do is you pick up your calculator, press 3 sine 45. That will give you 2.1213 minus 12. This will give you minus 9.8786. Okay. This would also give you 1 plus 3 cos 45, right, minus 6. What would that give you? That will give you minus 2.8786. All right, this is in newtons, this is also in newton. What you have done is that you have resolved the force on this question. So what is the next thing? Is for you to get a single force, because what you got is component of force, which is component of y and component of x. Do you understand? So for you to get a single force, we call it resultant force. Do you understand? So an examiner can ask you to resolve the force, and the examiner can decide to ask you to do resultant force. Okay, if the examiner asks you to resolve the force only, this is what you are expected to do. But if the examiner change the question and say find the magnitude, or the examiner say find the resultant, okay, to find the magnitude you have to say sum of f equals to square root of fx square, okay, plus sum of fy square. Now fx square, sum of fx square is what you've done here. Sum of fy square is what you've done here. So you just input the value. So what do? You say square root of, what do you have here? You have minus 9.8786, okay, all squared, plus minus 2.8786 all squared. Okay, now plus and minus cannot stay together, so put it in a bracket, put this in a bracket. By the time you press it, you're going to get a value for sum of f, okay, which will be a single value, and that's the resultant force, which means that you have combined the two together as one. But don't forget, let me show you something quickly. Now, whenever you press this value on a calculator, okay, if you press minus 2.87, okay, 86 squared on calculator, it will give you a negative answer, which is minus 8.2863, right? So what you do is you remove the minus, because you know that whenever minus, the bracket is telling you minus in two places, okay, because you're squaring the bracket. So minus times minus is supposed to be give you plus, but the calculator will give you the error. Do you understand? Except if you put the value in a bracket before squaring it, so you don't have an error. Do you understand? All right, that is that for this particular question. Let me quickly solve this here, and let's see what we're going to get for the second question. So I'm dealing with this now, right? Okay, now for this question, we don't have a force here. We have a force here, we have a force here, we have a force here and here. So the first thing to do is to check your angle, if they are placed rightly or not. Do you understand? Now, if you check this angle very well, you observe that the angle given is actually towards the vertical. Now, and you know that you're not to use the angle towards the vertical. Why? Because you're using cos for x-axis and you're using sine for y-axis. Okay, so what do you have to do? You have to solve for the remaining angle here, and that will give you 70 degrees. Since you know that everything is 90 for this particular region, just that. So which means that you're not going to use this angle. Now note that you can see some of your colleagues, right, that are using 20 degrees, and they would eventually get the answer for that resolution. Do you understand? But then that your colleague must or would not have used cos here while using the 20 degrees. He or she must have used sine, do you understand, to resolve towards the x-axis. Do you get it? But switching it for you, since you're just learning the method, right, or you're just saying this method, right, for the first time. Now, what you have to do as a student is to stick to what you know, which is cos and sine for now, okay? As time goes by, I will show you why it will work if somebody use sine, and it will work if you also use cos. Do you get it? All right, so let's just resolve and see how far we can go. Okay, so I have sum of fx. So there's no value here, right? I have sum of fy. There's no value here for both x, for x, right? So come here. What do you have? You have 2 Newton. Now the 2 Newton is actually on y-axis, which means that you don't need a sine or a cos for it. Okay, you just have to present the value, and you are presenting it as positive 2 because it was the positive y-axis. Now you're done with this because the force cannot have a component on x-axis at all, since it's a purely y-axis question, y-axis force rather. So you're moving here. This is purely x-axis, but don't forget that the x-axis is falling on is actually negative x. Okay, because it's negative x, what happens? you have to present the value like that because it's purely on x. Now, do you need cos any angle? No, you don't. Okay, why? Because if you press 7 cos 180, 180 is the default angle here. If you press 7 cos 180, it's going to give you -7. So why stressing yourself? Just pick it as one, -7. So you have -7. I'm putting the minus because it is towards the negative x-axis. Right. Now note that this 7 does not have any business with this 70 degrees here. Why? Because this one is purely on x. Now, anything that will use an angle here must be a force falling on z-axis, which is 3. Do you understand? So the 3 owns the 7 degree. Now the 3 now is falling on z-axis, but what we have to account for is only for x and y. So what do we do for the 3? Well, we have to resolve it towards x and towards what? Towards y. So resolving towards x, what are we going to have? We're going to have minus because we're resolving towards the negative x-axis. Hence, we're going to have -3. That's the negative and the force. Then we need the angle, which is going to be cos what? Cos 70 degrees. And it's as simple as that. Then you're not done with the 3 because you just resolve to x. You have to also resolve towards y. Now, which y are you resolving towards? You're resolving towards negative y-axis, right? In that sense, it means that the 3 is going to have minus as its sign. Then you have -3. What are you going to use? 70 degrees. But you are resolving towards x-axis and towards y-axis. And because we are resolving towards y, everything on y must be sine, sine, sine. Do you understand? So what are you going to have? You're going to have sine 70 degrees. The angle is not changing for both x and y. It's as simple as that. Then, what do you have last? This is the last force here. Okay, the force. Now, while bringing this here, it won't affect the 4 Newton at all. Now, pick the 4. What are you going to have? You're going to have -4. I presented it like that without an angle because it's falling purely on y-axis. Okay, by the time you press your value, you're going to have sum of f, which is, provided the examiner is asking you to look for magnitude or resultant. Then you have sum of fx squared plus sum of fy squared. But if the examiner only asks you to resolve, you just stop here. You just find your answer, right? Just press this calculator, you get the value. Now, I think that ends the solving to this particular question. Now, let me tell you why a student would actually use 3 sine 20, okay? If the student is coming here towards x-axis and the student decides to use sine, okay, the student must have used this 20 degrees, okay? So if you press 3 sine 20, okay, and this is student A, okay, this student A, and we have another student that is using my own method, which is the method you're learning now, okay? You have 3 cos 70, okay, 70 degrees. Both students are still going to get 1.026, and this will still be, by the time they press it on calculator, 3 cos 70 and 3 sine 20 will still give you 1.2026, which means that they are still doing the same thing. Do you understand? But the reason I asked you to stick with what you have here, cos and angle to the horizontal, is because of complex part of physics that I will still teach in time to come. Do you understand? So, and for you to follow my lecture back to back, you have to understand these differences and you have to choose your method. Do you understand? That does not mean that you should just be one way about knowing things. Do you understand? But this warrants that. Okay, I will see you in the next one. Now, before you go, please note that I will drop a question in the comment section. Okay, probably a link, a Google form link. Okay, that you just have to click on. Then that will direct you easily to questions and answer, or question basically. To submit that, just snap what you have solved and send. And if that is not possible, just snap what you have solved. Go to my bio, right? Just click on my profile. Go to my bio. You'll see on that profile, you'll see WhatsApp number 07016 blah blah blah. Do you understand? Just send it directly to that number. I would respond to you. Enjoy the rest of your day and see you in the next one.